Hello everyone. In this video, we will introduce the flood planning map available in the ARC GIS for Local Government Resource Center. The flood planning map is intended to provide flood planners with a set of tools and workflows to prepare for seasonal river flooding. These tools and workflows are based on real-world scenarios that have been used in previous flood years. Flood planning can be conducted weeks or months in advance of the predicted flood. This advance notice can save time in planning for protecting infrastructure and facilities or evacuating citizens within the impact area. In this video, we will demonstrate an overview of the sample data and tools provided with the map, how to determine the flood impact areas based on the predicted flood levels, how to identify public infrastructure, critical facilities, and vulnerable citizens that could be impacted, and how to create a budgetary cost estimate for proposed levies to mitigate the flood impact area. When you download the flood planning map, you will get a multi-scale ArcMap document designed for editing, an add-in for the editing toolbar, a toolbox containing 2 scripts for automating the flood planning analysis, the local government geodatabase with sample data from the city of Naperville, Illinois, and 2 documents including the Getting Started and Using the Flood Planning Map. The flood planning map comes pre-configured with sample data and tools. The sample data includes a flood planning base map, which is pre-configured at multiple scale levels, a flood management group layer, including inundation areas which are derived from hydrologic models, flood impact areas, in this case derived at 6, 8, and 10 feet above flood stage, municipal boundaries, and temporary levees. The public infrastructure includes sewer and stormwater layers. The vulnerable population includes locations of special needs citizens. And the critical facilities includes things like municipal buildings, parks, and fire stations. 2 flood planning tools are included in the flood planning toolbox. Each tool is part of an overall workflow and executed in sequence as indicated by their names. The first tool, called Step 1 or Create the Flood Impact Area, executes a Python script contained in the script folder which intersects the flood inundation area with the municipal or jurisdictional boundary. The second tool, called Step 2 or Create the Flood Impact Plan, also executes a Python script which intersects features from the selected layer with the flood impact area to populate the flood impact plan. The first step is to determine the extent of the potential flood impact to your community. This is accomplished by intersecting the predefined inundation polygons with the municipal or jurisdictional boundary. The example inundation data provided includes a feature class with several flood levels. First, select the inundation features. Then, select the flood level. In this case, we're going to select 5 because we already have flood levels 6, 8, and 10 defined. Then select the administrative area. We're going to select the municipal boundaries. Then enter a flood area name. And select OK to execute the script. When the script is completed, a new polygon feature is added to the flood impact area feature class. You can see here we have a new polygon feature with flood level 5. The new impact area will be intersected with the census blocks to determine the approximate number of people impacted and added as an attribute to the record. Repeat this process to create additional impact areas as necessary. It is wise to create several impact areas for multiple flood levels. These impact areas will be used in subsequent tools to identify the flood impact in your community. After the impact areas have been created, you can begin to identify features that will be potentially impacted at each flood level. In this step, we will identify storm sewer layers that have been impacted at flood level 5. We begin by selecting our input features. So we select the storm discharge points from the list. Then we select the flood impact area and the flood level. We enter in the flood level name we gave and the target impact table, which is the flood impact plan. Then we select OK to execute the script. The results are written to the flood impact plan, which will be assigned action items to protect the community assets. To view the results on the map, we will need to create a table join between the flood impact plan and the storm discharge points. The join will be created using the facility identifier with the flood impact plan using the feature ID field. We'll leave the join option set to keep all records to ensure that we can see the impacted features at all flood levels. After the join has been completed, we can create custom symbology to show the impact. We'll use the flood level field that came from the join, add all values, and remove the null values so that we can see them only at the flood levels that we've selected. I'm going to use a color ramp to be consistent with the other feature classes. I've already done the storm gravity mains, so we'll turn those on so that we can see the features that are impacted at each of these flood levels. A levee feature class is provided with the local government information model. You can use this feature class to load your levees into if you've previously created them or received them from an engineering firm. In addition, a feature template is provided to create levee features if you don't have any. To create a levee, use the Start Editing option in the Editing toolbar. The levee feature template has several material types that you can use. Select one of the material types and then a construction tool. Draw in where you want your levee to go and double-click when it's finished. And don't forget to save your edits. It is important to understand this is not an engineering design tool, but a flood planning tool and should be used for that purpose. The levee feature tool does not tell you where to place your levee or how to build them, but it does help you determine what the effect of levee mitigation efforts will be to your community. The Attributes Assistant add-in can be used to assign attributes and calculate the cost estimate for levee materials. Select the Attributes button in the Editing toolbar to open up the editing window. You can see our material set to clay. We're going to enter in a height of 10 feet for this new levee, a bottom width of 30 feet, top width 8 feet, and a side slope of 3:1. For the location description, I'll just enter on south side of the river. You can see that the cubic yards has been calculated for us, and a default value of $35 per cubic yard of material. We can override this if we have a different number. And now we have a budgetary cost estimate for our new levee. There are a number of ways to share the results of our flood planning analysis with others. You can print a map and give it to staff who do not have internet access. You can create a map package and upload it to your ARC GIS Online account to be shared by others who have ARC GIS, or you can publish a map service to be used inside of a web-based application. In this short video, we have introduced the flood planning map and demonstrated how it can be used in preparation for seasonal river flooding. We encourage you to try the map with sample data using the documents provided with the download. After you have used the flood planning map, you can configure it with your data. We look forward to hearing your feedback. Thanks for taking the time to watch this video.